So this video is related to radical functions. So let's start off with what is the parent function. So that's going to be f of x equals the root of x. Oops. Okay, so if I were to graph this, what would it look like? Well, when x is 0, f of 0, it'll be 0. If I put in x is 1, the root of 1 is 1. And when x is 4, the root of 4 is 2. So I will get something that looks like this. Okay, so a way to remember maybe what the shape of root x looks like is that you can think of, also one of my teachers told me, if you're pulling a root out of the ground, if you're weeding, then you kind of pull it out in this arc shape. So, I don't know, pulling a weed out of the ground, if you are to do weeding, if you saw my backyard right now, you would see that I do not do weeding, and it is kind of a jungle out in the backyard. Okay, so pulling out weeds. So the domain of this function is going to be from 0 to infinity. So I can't put any negative values for x in here because I can't take the square root of a negative number when I'm dealing with real numbers. So my domain is going to be from 0 to infinity. My range also is going to be from 0 to infinity. You see that I never drop below the x-axis in the parent function. And then I only have the one intercept of the origin. Okay, so let's see just some general ideas related to transformations of radical functions. Okay, so I started with y equals root x as my parent function, or f of x equals root x. Let's use f of x. Okay, so that was this graph here. Now what if I wanted to shift that graph, I wanted to shift that picture up 2 units. So what I would do then is I would add 2 outside. So if I want to shift it vertically up 2 units, I would just add 2 outside of the root. So I'd go up 2, and then from this point up, so it's here, so 1, 2, and then this point 1, 2. Okay, so there would be my shifted graph in the blue. So if I wanted to shift it down, my parent function down 2 units, okay, so say I want to shift it down 2 units, so what I would do then is I would just do subtract 2. So I would take every point on my parent function and move it all down 2 units. So starting there, taking this one, 1, 2, and then this one down 1, 2. Okay, so that's vertical shifts. I just add or subtract them outside of the radical. So now if I want to do horizontal shifts, let's say if I want to do a horizontal shift, what I do is I'm going to, let's get rid of these ones here. So a horizontal shift left or right, I'm going to have to add or subtract numbers underneath the radical. So if I want to move 3 units to the left, what I'm going to do then is I'm going to have to go plus 3. So it might seem a little bit backwards that I want to go 3 units to the left, so I add 3. But if you think about it, if I put in negative 3 in there for x, that will give me 0. So negative 3 plus 3 will be 0, and the square root of 0 is 0. So adding 3 means I'm moving 3 units to the left, so this point's going to be here, this point's going to be 1, 2 here, and this point 1, 2, 3 here. So there is my radical function, move 3 units to the left. So now if I wanted to move it, say, 2 units to the right, just my parent function, the pink one, 2 units to the right, then what I would have to do is if I'm moving to the right, I'm going to have to go subtract 2. So taking my parent function, which is the pink one here, let's erase, we'll get rid of this blue one. So I'm taking each point, and I'm just translating it 2 units to the right. So this one from the origin goes over 1, 2, so it's going to be here. And then this point 1, 1 comes 1, 2 there, and this one's going to go off my graph, but that's okay. So it's going to look something like that. Okay, so those are shifting vertically and horizontally. So now, if I want to, we can also flip the graph. So let's say I want to flip the graph over the y-axis. Okay, so I want to flip it vertically. So I'm trying to flip over this line, the y-axis, x equals 0. So what that means is I'm changing the signs of my x's to get them over to the other side. So I want to end up having a picture that looks like this instead. Okay, so I want that mirror image on the other side. So the equation for that then would be f of x equals the square root of negative x. Okay, so if I want to flip over the horizontal or the vertical axis rather, then I'm going to have to change the sign inside the radical. Okay, and then if I want to do a horizontal shift, so if I want to flip this over the x-axis, I'm going to have to change the sign outside of the radical. So let's say that's g of x is equal to negative root x. So what's going to happen there is that these points are going to drop down here. Okay, so let's just see a couple examples and how this works with some numbers. Okay, so the first one here, I have a flip and I have a shift. So I'm flipping it, I'm changing the signs of the x's, so I'm flipping it over the y-axis, and then I'm also shifting it 1 unit to the right. So what I would start with when you're graphing these is I would start with the parent function. So the parent function I'll do here in pink. Okay, so that's my original parent function. So the first thing I want to do is I want to do any flips. So I'm going to flip it over my y-axis first. So let's say that's the green, so it'll be here. Okay, so all I've dealt with so far is this flip. And now if I want to do the shift, so now I'm going to go 1 unit to the right. So I'm going to take, because it's -1, so I'm going to go 1 unit to the right. So now I'm taking those points from my green graph. Let's erase the parent function. We can get rid of him now. And I'm going to move these points 1 unit to the right. So this one moves here, this one moves here, and then this one moves here. So then my final graph, I'll erase this intermediate graph here. So my final graph would be this purple one, and this would be a plot of the function here. Okay, so then what is the domain of this graph? Well, my domain is, I can see visually that I can go from -infinity for values of x all the way up to 1. So I get a problem once I go past +1, and you can look to see why that is. So if I put something like 3 in here, what happens is I'd get 3 minus 1 is 2, but then I'd have a -2, which I know I can't do. So the domain here is going to be from -infinity all the way up to and including 1. And then my range, I haven't shifted it up or down, so it's still going to be from 0 to infinity. And then my intercepts, I have 2 intercepts, an x and a y-intercept. So my x-intercept happens at 1, 0, and my y-intercept happens at 0, -1, which were nice, and I found those just by doing my transformations and my shifts. Okay, and let's see one more quick example. Okay, so in this one I have another flip, and I have a vertical shift and a horizontal shift. So again, the flip, I'll deal with that first. So if I go back to my parent function here, so let's start with that. we'll always refer back to that first. So this was my just root x. So now I want to flip. This means the negative sign out here means a flip over the x-axis. So I'm going to do that first. I'll do that in purple. So I'm going to flip it over the x-axis. So 0, 0 stays the same, but then these points drop down to here. So it mirrors over there. I'm going to get rid of that parent function. Okay, so I've dealt with the flip, and now I have to deal with the shifts. So I can do both the shifts in one step if I want. So I'm going to go right 1 unit and up 3 units. So each point is going to go right 1 unit. So I'm going to go right 1 and then up 1, 2, 3. So my point of my origin moved to this new point here. So this point at 1, -1 is going to go right 1 and up 1, 2, 3. And then this point here is going to go right 1 and up 1, 2, 3. Okay, so I'm going to get a picture of my final graph that looks like this. It's a little bit messy, but get the idea. So then here my domain is going to be from 1 to infinity, including 1, right? Because I can start at 1. I can't go anything less than 1. If I try to do that, I'll end up with something negative under the radical, which I know I can't have. My range is going to be from, now it's going, my radical function is going downwards, so from my range is -infinity all the way up to 3 is as high as I can go. So I'm going from -infinity, all the way up to 3. And then my intercepts, well, I don't have any y-intercepts, but I do have an x-intercept. I just can't see it on my graph because I haven't extended my x-axis far enough. But if you want to solve for it, what you do is you have to make g of x equal to 0. So you have 0 equals negative root x minus 1 plus 3. And then what I do is I move the 3 to the other side, and then I can divide by the negative. So it would be -3, but divided by negative will give me a positive 3. Root x minus 1. So this is just a quick review. To get rid of that radical, what I do is I square both sides. So that's gone. So then I'll have 9 equals x minus 1. Add 1 to both sides, so I get x equals 10. So I have an x-intercept at 10, 0. Okay, so that's it. Thanks for watching. Good luck with the assignments.